source of a strange radio signal that's coming from below the ice in Antarctica.
A scientific enigma has emerged from the depths of Antarctica.
But the current understanding of particle physics make it hard to explain the signal's source.
Above Antarctica's ice, this is the photo. What the hell is that thing? Holy moly.
Welcome, curious minds, to another deep dive. You ever think about how the quietest places on Earth, these really desolate spots, can sometimes hide the biggest secrets?
It's often the case, yeah.
Well, get ready, because we're diving into one of those places today. The huge, empty, frozen world of Antarctica. But we're not talking about icebergs or penguins this time.
No, something much stranger.
Much stranger. We're looking at these bizarre, totally unexplained radio signals. And the weirdest part, they weren't detected coming from space, but shooting up from deep under the ice.
Yeah, that's a kicker.
This isn't just, a bit of static. It's a real scientific puzzle. Something that seems to break the rules of physics as we know them. Okay, let's unpack this.
What's fascinating here, and it's why scientists are so intrigued, is that this isn't just some minor glitch. We're talking about top physicists, people who map out the universe, kind of scratching their heads.
Right, they just can't easily explain it.
Exactly, it simply doesn't fit the standard models. It's a genuine mystery.
And that's our mission for this deep dive. We're going to dig into what these signals are, where they might be coming from, and, well, why they matter so much. We've got the research papers, the scientific reports, and we'll walk you through this icy enigma. So, first things first, let's set the scene. We need to talk about the experiment itself, the ear listening to the cosmos, if you will. It's called the Antarctic Impulsive Transient Antenna, or ANITA for short.
Much easier.
Definitely. Now, ANITA isn't like a telescope stuck on the ground. Picture this. It's a whole array of instruments hanging from these massive science balloons, way up high in the stratosphere.
Yawn up.
Yeah, like 40 kilometers. That's about 29 miles floating above the ice. And its main job, its mission, was to hunt for really high-energy cosmic rays and these super elusive particles called neutrinos.
The ghost particle.
Exactly, the ghost particles coming from the furthest edges of the universe, supposedly carrying secrets about, cosmic explosions and stuff. ANITA was doing this listening work between 2006 and 2016. It's a NASA-funded project.
And if we connect this to the bigger picture, you have to ask, why Antarctica? Why go to all that trouble in such an extreme place?
Good question. Seems like a tough spot to work.
It is, but it has one huge advantage. It's incredibly remote. Almost zero human-made radio noise. No FM stations, no TV broadcasts, none of that static that drowns everything out elsewhere.
Ah, okay. So it's radio quiet.
Extremely quiet. It's basically the perfect place for deep space listening. If you want to pick up the faintest whisper from billions of light years away, you need absolute silence. Antarctica gives you that.
So just to picture it, instruments on balloons, way up high, 29 miles up, listening for signals coming down from space. Makes sense. That was the plan.
That was absolutely the plan. Standard procedure for this kind of cosmic ray and neutrino hunting.
But then, things got weird. Really weird. ANITA started picking up something completely unexpected.
Yep, the anomaly.
Instead of just signals raining down from space like it was built for, it detected these strong radio pulses shooting upwards. From inside the ice sheet?
Upwards, from below the detector.
Let that sink in. Signals coming up from the ground. That's just not supposed to happen.
Right.
It's like setting up your satellite dish to get TV from space and suddenly picking up a clear signal coming from your own basement.
It's fundamentally counterintuitive, physically speaking.
Totally. It just doesn't make sense with how we think these things work.
And this raises an important question. Why is it physically so puzzling? Stephanie Wissel, she's an associate professor, physics and astrophysics at Penn State, she put it really clearly.
What did she say?
She said, the radio waves that we detected were at really steep angles, like 30 degrees below the surface of the ice, coming up at a steep angle.
30 degrees below the horizon, coming up.
Exactly. Now, think about high-energy particles, like neutrinos. If they were coming from space, hitting the Earth on the other side, and somehow traveling through the planet to trigger the signal, well, that's the problem.
Why is that a problem?
Yeah.
Don't neutrinos pass through stuff easily?
They do, but high-energy ones are different. They should interact much more readily. Traveling through thousands of kilometers of rock and Earth's dense core, the standard model says they should be absorbed. They shouldn't make it through intact.
Ah, okay, so the journey itself should stop them.
It should dramatically weaken or stop them. Wissel said, if we detect them, it means they have traveled all this way without interacting with anything else. which is incredibly unlikely for known high-energy particles over that distance, or they interacted in some totally new way we don't understand.
That's the crux of it then. Either they survived an impossible journey, or something else is making these signals.
Precisely. It defies the known rules.
So, just to be super clear, what specific physics rule is being bent here? Is it the standard model itself?
It's challenging our understanding within the standard model, specifically how high-energy particles interact with matter, what physicists call the cross-section. Think of it like the probability of hitting something. For a known particle to zip through thousands of kilometers of Earth, it needs a tiny, tiny cross-section, an incredibly low probability of interaction. But then for it to interact just right near the surface to produce a detectable radio pulse, that combination is the puzzle.
Well, so it needs to be both stealthy and loud at the end.
Kind of, yeah. It suggests either a particle with properties we haven't measured or accounted for, or maybe an interaction we just don't know about yet. It's a fundamental mismatch with our current physics toolkit.
Wow. Okay, that's the aha moment for you listening. Finding something that, according to the rulebook, simply shouldn't exist. It's like finding that perfectly intact glass bottle after it was supposed to be crushed.
It's a major anomaly, yes, a potential crack in the foundation.
So naturally, the first suspect, especially for an experiment like ANITA looking for neutrinos, had to be neutrinos.
Absolutely. That was the most logical first thought. Neutrinos are famously elusive, the ghost particles. Trillions pass through us every second without a trace.
Right, we hear that all the time.
But detecting the high-energy ones is a huge deal. They come from violent cosmic events, supernovas, merging black holes, active galaxies, things light years away. They carry information we can't get any other way.
So maybe these were just super weird high-energy neutrinos doing something unexpected. That was the hope.
That was definitely the initial hope. Maybe they'd found a new population of neutrinos behaving strangely.
But they ruled that out. How?
Well, what's fascinating here is the scientific rigor. They didn't just stop at ANITA's data. They cross-checked everything meticulously with results from 2 other major neutrino experiments, independent ones.
Okay, comparing notes.
Exactly. Building confidence, ruling things out, and the conclusion was pretty definitive. The characteristics of these ANITA signals, particularly their angle and polarization, did not match previous neutrino experiments.
They just looked different from confirmed neutrino signals.
Significantly different, which led them to conclude these signals probably weren't from neutrinos at all. They had to be. Well, something else entirely. As Wissel put it, this left them in uncharted territory.
Uncharted territory. Wow, okay, so you mentioned angle and polarization. Can you break that down a bit? What specifically didn't match?
Sure. So physics predicts that if a neutrino interaction deep in the ice created a radio pulse, that pulse would bend as it travels out, exiting the ice at a relatively shallow angle due to refraction Snell's law, basically.
Like light bending through water.
Precisely. But ANITA saw these signals coming up at those really steep angles, almost straight up, like 30 degrees below the horizon. That's hard to explain with standard refraction. And then there's polarization, the direction the radio wave wiggles.
Okay.
The polarization ANITA saw didn't line up with what you'd expect from a standard neutrino interaction in ice, based on theory and what other experiments had seen with confirmed neutrinos. The combination of that steep angle and the wrong polarization was the real killer for the neutrino hypothesis.
Got it. So the evidence just didn't fit. Neutrinos are out. So
Yeah.
what theories are scientists floating around now? If it's not neutrinos, what could possibly be doing this? We're talking beyond standard physics here, right?
We are, and people are getting creative, exploring some pretty mind-bending possibilities. One idea that gets mentioned, though it's very speculative, involves dark matter.
The invisible stuff that makes up most of the universe.
Exactly. The theory goes, maybe there's a type of really heavy, weakly interacting dark matter particle that can pass through the Earth mostly untouched, but then decays or interacts right near the surface, producing these radio waves.
Huh.
Possible. Theoretically possible, maybe. But there's zero direct evidence for that specific kind of dark matter interaction yet. It's way out there. Stephanie Wissel herself mentions something a bit more, well, grounded, but still unknown.
What was her thought?
She said, "My guess is that some interesting radio propagation effects occur near ice and also near the horizon that I don't fully understand." Basically acknowledging that maybe the way radio waves travel through kilometers of ice, especially near the event horizon angle, might have some weird quirk we haven't figured out.
So maybe it's not a new particle, but weird ice physics.
It's a possibility she raised. It shows the honesty of the process admitting when the current understanding might be incomplete. even about something seemingly straightforward, like radio waves in ice.
That feels like a scientist saying, look, we've checked the usual suspects, they don't fit. Now we're looking at stuff we genuinely don't grasp yet. So what are the implications here? If it's dark matter, or new physics, or even weird ice effects, what does that mean?
Well, if we connect this to the bigger picture, the crucial thing is, as Wissel stressed for any of these ideas, there's no conclusive evidence to support that yet. They've ruled things out, but haven't ruled anything in.
Still a mystery.
Very much so. And the implications are huge. Could it be a totally new particle, one that forces us to rewrite the standard model? Could it be a sign of some unknown fundamental interaction? Or, stretching further, could it be something even more exotic, whispers from somewhere unexpected?
It forces you to ask really big questions.
It absolutely does. It pushes the boundaries of what we think we know. It's not just filling a gap. It might be revealing a whole new landscape in physics.
And that, I think, is what's so exciting for you listening. It's rare to find something in science that just flat out doesn't fit. It tells us the universe still has some major surprises up its sleeve.
Definitely. It's what drives science forward.
So let's wrap this up. We've got Antarctica, this super quiet place, suddenly sending signals up from beneath the ice. ANITA, the experiment listening for cosmic whispers from above, caught these shouts from below.
Shouts that defy physics as we know it.
Right, and the prime suspect, high-energy neutrinos, they've been ruled out pretty definitively after careful checks against other experiments. Scientists are now exploring ideas from dark matter to unknown effects in the ice itself, but nothing fits perfectly yet.
It's an open case, and the scientific community knows that more data, more experiments are absolutely key. This isn't something you solve with just theory. You need more observations.
So the search goes on.
Oh, yes. People are already designing the next generation of experiments, hoping to get a clearer picture, more signals perhaps, that might finally crack this icy enigma. It's a major puzzle they're determined to solve.
So what does this all mean for you? What if these are whispers from some realm we haven't discovered? Or just the first hint of a revolution in physics? Maybe it's dark matter saying hello, or particles behaving in ways we never imagined. We don't know. Until science gathers more clues, the source is a tantalizing question mark buried under miles of ice. So keep an ear out. Antarctica might just be trying to tell us something big.